Hey, what's up, guys? I'm Mohit K. Kashyap, studying in Sri Venkateswara College of Engineering, currently pursuing my BTech in Electronics and Communication. So today we're going to learn about the subject microwave and antenna. So let's get started with going on to the next slide. So what is microwave? That's my first question. What do you guys mean by microwave? So microwave is a form of electromagnetic radiation with wavelengths ranging from about 1 meter to 1 millimeter, corresponding to frequencies between 300 megahertz and 300 gigahertz respectively. So as you guys can look at this small tree diagram, here the tower, the FM, TV and the radar comes under radio waves. The TV remote and a bit part of light bulb comes under infrared rays, and the bit part of light bulb and sun comes under ultraviolet rays, while the X-ray machine comes under the X-rays, and the radioactive elements such as uranium, radon, they all come under gamma rays. So as we look at this wavelength of the all the waves, the wavelength of the first wave is 100 meters, the radio waves ranging from 100 meters to 1 centimeter, and the wavelength of the infrared rays ranging from 0.01 centimeter to 1000 nanometers, and the wavelength of ultraviolet rays is 10 nanometers, and the wavelength of X-rays is 0.01 nanometers, and the wavelength of gamma rays is 0.001 nanometers, which is the least of the least, which is compared to the size of an atom. So moving on to our next slide. So, so moving on to our third slide, we are going to discuss about the advantages of microwave. So there are four advantages of microwave, which is increased bandwidth availability and improved directive properties, less fading effect, and power requirements are really low. So these are the four advantages of microwave. And moving on to the next slide. Here we are going to discuss about the application of microwave such as telecommunication. What do you mean by telecommunication? Like it is used in 4G technology, 5G technology, and upcoming 6G technology for Wi-Fi's and for Bluetooth, etc., etc., etc. For commercial and industrial applications, like many things like radars, etc., etc. The next point is radars. For commercial industrial applications, it is used in healthcare field like MRIs and CT scans. There are many kinds of microwave waves are used to detect a disease. So it is used in radars for transmitting and receiving the signals. The way we talk, we are able to talk in our phones. This is done by the radars. So the last one is microwave semiconductor devices. So it is semiconductor devices which are used in many electronic devices such as laptops, TV, etc., etc., etc. So moving on to our next slide. So in this slide, we are going to discuss about reflex klystron. So as you can look at this diagram, it's a pretty huge tube. So what is a reflex klystron, guys? So a klystron is a specialized linear beam vacuum tube invented in 1937 by American electrical engineers Russell and Sigurd Varian, which is used as an amplifier for high radio frequencies from UHF up into microwave range. Okay, moving. So this is what a klystron is. So moving on to our next slide. What we have is over here is this thing, guys. So what are the mode curves of reflex klystron? So 1 into 3 by 4 quarter and 2 into 3 by 4 quarter are the most commonly used modes in a practical reflex klystron. The reflex klystron operates in a different mode for each additional cycle that the electrons remain in the repeller field. Mode 1 is obtained when the repeller voltage produces an electron transit time of 3 by 4 cycle. Additional mode follows in sequence. Mode 2 has an electron transit time of 1 into 3 by 5 cycles. Mode 3 has an electron transit time of 2 into 3 by 4 cycles. So I guess I have made clear about the mode curves of reflex klystron. So moving on to our next slide, what we have here is so I have plotted the graph for repeller voltage. So as you can see the graph, the center, this is our center point mode and this is our half power points. Okay. So this is our electronic tunic range, ranging from 3000, ranging from 2995 megahertz to 3005 megahertz, and the same goes for all the modes, mode 1, mode 2, and mode 3. So moving on to our final slide. Thank you guys for watching this video. I hope you guys understood what I was trying to teach you guys. So thank you guys for, please like and subscribe. Have a good day. Thank you. Thanks a lot.